Okay, well, good morning, everyone. My name is Olivia Mangum. I'm going to be kicking off the event for us today. Thank you guys so much for joining us at our Mastering OpenShift workshop. So before we begin everything, I will just be taking you guys through a little spiel of who Fierce Software is, our partnership with Red Hat, and what you can expect during the workshop today, and what you can see after the workshop is over, just the content that we'll send over afterwards and follow-up materials. So, Fierce Software is a small woman-owned business specializing in reselling enterprise open source for our public sector customers with a specific focus on federal system integrators. Specific value-add elements that we bring are innovation brokering, license management, professional services, formal training, and custom enablement technology workshops. Our perspective as a reseller means that when we hear our goals and technology challenges, we respond with the perspective of our portfolio and not as a single vendor solution. We love to be an innovation broker, getting our customers access to the smartest people and best technology we can find. We like to hear the entire challenge and then take ownership of finding our customers a complete solution. In addition to being an innovation broker, we offer several other value adds. If you need professional services as a part of an ongoing install or professional expertise, we work with vendor professional service teams and we can bundle those for you. This is both for uncleared and cleared resources. We will also provide access to formal training. Today's workshop is an example of one of our technology enablement workshops that we offer here at Fierce. If you see anything today that fits, we'd love to follow up with you. If this wasn't a fit, let us know where we can fill in the gaps for your specific needs. We'd love to help you and your team out. Now, here from Red Hat today, we have Catherine Brady, who is an inside sales rep on the Federal System Integrators team over at Red Hat, and then we have Ryan Maharaj as well. So they will be able to help with follow-up materials and answer any questions you guys may have after the workshop's over. And then our speaker today is going to be, agenda at a glance. So today, from our speaker, Ivan Mikvinsky, he will be going over the S21 process in OpenShift, rollback replication and recovery using labels in the OpenShift platform, the CI/CD pipeline, and blue-green deployment. Now, introducing our speaker, Ivan Mikvinsky. I listed his email here as well if you guys have any follow-ups specifically for him after the workshop. But Ivan is a systems architect, network engineer, and application developer with a major focus in Linux and open source software solutions. He is a qualified Red Hat certified instructor and a Red Hat certified examiner. And then if formal training is something you and your team are looking to get your hands on, our new and improved Fierce Web Store has a vast showcase of the many training courses Red Hat offers. After the event ends, you'll be receiving a recap email from myself. And again, if you have any questions left over, please feel free to reach out to myself, Kat, or Ryan, or even contact Fierce directly with the given email aliases. Now I'm going to go ahead and pass the mic over to Ivan.
Thanks, Olivia. All right, let me set up the screen share here. And I'm going to share this screen here. All right, so welcome to the OpenShift 101, OpenShift 4 101 course. And if you have not attended one of these workshops before, quick overview of what we're going to be doing today. We're going to be covering as source to image, as S2I, rollback replication and recovery. And we're going to be doing all of this through the OpenShift infrastructure. We have a deployed OpenShift infrastructure, and we have logins for every user that's going to be logging into the system. And I'll give you guys the authentication and login terms for that. as we get through the welcome and lab 1 is where we'll get access to our specific instances and be able to log into the OpenShift infrastructure to be doing all of these exercises. Let me share the link for the workshop. Share the link for the workshop in the chat here so that you can get access to that. Oh, yeah. All right. So what we're going to be doing is we're going to be starting on that web page there, and down at the bottom of that page, we're going to enter in some details in order to get access to our specific instances. And that will allow us to do all these lab exercises that we've got listed here. We have 9 major lab exercises with a couple of sub breakout exercises in each one of these labs. And down here, down at the bottom, what we're going to do is we're going to fill in the workshop details down here at the bottom. So we're going to click on the Configure Workshop button is the first thing we're going to do. And then we're going to fill in some information. First, go ahead and pick a student ID. I picked 20. That's the student ID that I'm going to use to demonstrate the lab exercises. The domain that we're using today is fiercesw.network, so make sure you use the drop-down and pick fiercesw.network. And today's workshop is OCP4-101, and that's all lowercase, OCP4-101. I'll put that into the chat notes as well. So let's make sure that we fill in these details down at the bottom and then click the Enter button. When you click the Enter button, there's a bit of JavaScript that's going to go through the rest of the lab web pages for your specific instance to give you the right URLs that you can copy and paste in order to bring up the right web pages for the lab exercises. Go ahead and click Enter there. Make sure that the workshop details now reflects the domain, fiercesw.network, the workshop OCP4-101, and the student ID that you picked. All right. So the next thing we're going to do is we're going to verify some prerequisites. There is one lab exercise where we are going to be using GitHub, and we're going to be using GitHub to fork a repository that's already pre-created for us. We're going to be changing one line in one file in that repository in order to execute what's called a GitHub trigger, which will tell our OpenShift infrastructure to redeploy our application based on a new developer commit. So make sure that we have a GitHub account. You can sign up for one using the link there if you don't already have one. I already have one, so I'm not going to walk through that process, but if you need any help walking through that process, let me know. Excuse me. And what we're going to do today in terms of the lab exercises is we're going to take a break after I describe the lab exercise. I'm going to give you 5 to 10 minutes, depending upon the complexity of the lab, to walk through it yourself, and then I'll walk through it with everybody afterwards. So before we get to that, let's talk about some key terms, some important terms to note when talking about OpenShift and OCP. OCP is the OpenShift Container Platform. So anytime you see OCP, it's referring to an OpenShift installation that is part of Red Hat's branded distribution of the container technology under the covers and upstream known as Kubernetes. However, Red Hat packages a lot of extra bells and whistles with Kubernetes in order to create the OpenShift Container Platform, which makes it stupendously easy to use, deploy, manage, and update applications in as a developer and use as a developer. So a couple of the key terms we're going to be talking about through these lab exercises is a container. This is a specific piece of software that's wrapped up into a complete file system, and that's usually packaged and delivered as an image. That's used to be historically known as Docker images, but now they're really referred to as container images. And these are typically read-only images. Once you've got an image and you use that image to create a running application, that running application is then the container itself. An image stream is the way that we track where the images come from and what they're consisted of and how they're constructed. Images can be constructed with sub-images. And a pod is a set of containers that are running together in order to provide an application or a service. That's the common DNS name used to access whatever is running on that set of pods or replicated pods. A project is the logical grouping of everything that's related to a specific service. The deployment is how we can update our application or change configurations or images that are running for our application. A build is the process of turning our source code into a runnable image. And that's one of the first things we're going to do, is we're going to take some source code and we're going to turn it into an actual container and then run that. We're going to take some source code, turn that into an image, and then run that as a container inside a set of pods with service on the front end that allows us to access that. Build config is the configuration that tells OpenShift how to build that container, that image. The route is the DNS labeled and mapped network path that's used to get into that application. OpenShift also has the concept of operators, which is usually a packaged specific set of applications in order to enable certain types of functionality, either within OpenShift or make that functionality available as a service to users or operators outside of OpenShift. Cluster masters are the systems that are used, essentially the foremen for the OpenShift infrastructure that maintain and manage everything that runs inside of it. And the cluster workers are where our applications actually run. All right, so we're going to use this terminology quite a bit throughout these lab exercises. So don't worry if you don't understand what all of these things are and how they differentiate each other from themselves just yet. But it's a good reference set of terminology to become familiar with once you're talking about containers and container infrastructures. So in this next lab here, I'm going to give you guys a few minutes to just play around with the OpenShift infrastructure. Now, if you filled in the right details in the workshop configuration down at the bottom of the page, and what you'll see is that this is going to be replicated and available down at the bottom of each page. Filled in the right details at the bottom of these pages, these URLs that we see here are going to reflect that information. For example, we've got the right domain and we've got the right workshop name as part of the URL. You can cut and paste this into a new tab, and that'll give you access to your instance in OpenShift. Now, the first thing that's going to happen is you're going to need to log in. So the login is going to be your student ID number. In my case, that's student 20. And let's see here, we're going to use user 20. And then the password that we've got for everybody here is, let me go back to that password where I set that. Oh boy. Give me 1 second. I seem to have lost the page where I had the password. Well, bear with me 1 second. I'm fat fingering this for some reason. There we go. Shift. The password that I set for this is, there we go. So I'm going to paste the password into the chat. So the password for everybody's login is going to be the one that I've just pasted into the chat. One thing to note is that this environment will be up until tomorrow afternoon, a little bit about the same time tomorrow. So if you want to do these exercises or repeat these exercises, you're more than welcome to over the course of the next couple of days. Keep in mind that you will get an SSL certificate warning error. We used a self-signed certificate that's not set up as part of a certificate is not signed by a certificate authority, because that, one, would be expensive, or two, put undue load and stress on the Let's Encrypt free certificate authority infrastructure that exists. So we're using self-signed certificates. So you may have to click through some certificate warnings in order to get access to this lab infrastructure for this workshop today. All right, so let's take a couple of minutes and go in, log in through the web console. If you have any issues logging in through the web console, please drop a note into the chats, and myself or one of my assistants will help you get logged in. And let's take 5 minutes to go ahead and do that. All right. So let's go ahead and walk through this together. So first thing we did is log into the web console. Copy and paste this URL right here that I've got from the workshop. And user is the user, the student ID that you set at the bottom in the workshop configuration. Password's been pasted into the chat. Go ahead and log in. Make sure you click through the SSL certificate warnings because we are using a self-signed certificate for this workshop today. Now, once you logged in, you get dropped into the topology page, which shows you all of your projects. Right now, we don't have any projects because we haven't created any. So we're going to go ahead and create our first project. When we create our project, there's essentially not going to be much to it. Let's see here. We're going to create our project, and I believe, yeah, that's right. We're creating a terminal project. This is going to be an important project that we're going to create because we're going to need this for the subsequent exercises that we're going to be doing. So let me see here, create a project. I'm going to call this project Terminal 20. Make sure you give it a unique name, give it the ID number of your student ID. And I'm going to give it Terminal 20 as the display name. I'm going to go ahead and I'm going to leave the description blank for the time being. I think we put in a description. I think we might in this. Here, create new project. They fill it in as Terminal 49. Oh, they don't even give it a display name. I'm going to give it a display name. I'm going to go ahead and create this project. And then the next thing I'm going to do is I'm going to deploy a standard container, a standard application to this project. And that's going to be one that's prepackaged and available as part of the OpenShift deployment. We're going to launch a terminal here. At the top of the screen, we're going to click on this greater than underscore symbol, and that's going to deploy a terminal for us. Initialize terminal for our project. This terminal we're going to use in subsequent lab exercises. This workshop has lab exercises in both command line form as well as the web UI form. So we have instructions for both to walk you through how to do things from the command line as well as how to do things from the terminal. Let me see, OC project. Projects. One project on the server, and that's the Terminal 20 project on this server. Yeah. Right. So we can play around with the terminal operator. So what we've done here is that we have essentially loaded a container image, an operator, which provides us with the application and everything else that we need for that, called the Red Hat terminal operator, OC get projects. What you'll also notice is that because this is launched from within OpenShift, it's already available to talk to the OpenShift infrastructure from within OpenShift. If you were to try to access OpenShift, there's a little bit of work that you would need to do. First, you need to install the OpenShift client, OC, on your system, and then you'd have to also install or set up the credentials in order to access the OpenShift API. And we'll talk about that a little bit later. All right, so let's see. In order to get the services, deployment configs, build configurations, active deployments, this is going to come in handy. OC status. This is a very useful command that you're probably going to want to use quite often. So let's go ahead and run the OC status command. And what we'll get here is that we have project terminal 20 running on this server internally. And it has a service with this workspace -service. This is the IP address that's been made available and deployed inside the pod. There's a deployment available to that. We'll talk about what all of this means as we continue on through the lab exercises, through the workshop today. All right, so at this point, we're essentially ready to get started with our lab exercises. What we've done is we've instantiated a terminal project in order to be able to use the command line to access our infrastructure. Again, keep in mind that pretty much everything we're going to be doing today can also be done directly through the web UI. You do not need a terminal, but we've instantiated a terminal inside our infrastructure that we can use to create exactly the same things we would through the web UI. All right. So let's continue on to lab number 2. And in lab number 2, let's say I have developers already working with Docker on their workstations, or maybe they've built out a basic Kubernetes infrastructure, which is no small feat and no easy task. OpenShift is by far much easier to install than a Kubernetes infrastructure on your own. But let's say we've already got Docker containers that are in use in our infrastructure and environments, and we want to port those containers or run those containers in our OpenShift infrastructure. Well, we can do that as is shown here in this next lab exercise. We can bring our own OCI compliance image. And OCI stands for the Open Container Initiative, which was a consortium of all sorts of technology companies that came together and came up with a standard for container images. So if you have an OCI compliant image, deploy those inside of OpenShift. And again, we give instructions here for using the command line interface, which you have available to you through the terminal that we've just set up, or we can do this through the web console. I'm going to walk this one through the web console. Now, in order to do that, we do have to change context. We're logged in right now as an admin, or no, yes, we're logged in right now as a developer, but we can also be an administrator for our specific instance of OpenShift here. So right now we're logged in as a developer. In order to deploy applications, we need to be a developer because the administrator is used for administering how some of those applications work within OpenShift. Deploying applications is done by developers inside of OpenShift. So we're going to keep our developer context right now that we've got OpenShift, and we're going to create a new project, and we're going to call this project Demo 20 inside of OpenShift. Again, keep in mind that if you want to do this through the command line interface, you have those command line interface steps available to you. So this project that you're going to deploy is a Rails PostgreSQL example application, and I'm going to give everybody another 5 minutes to go ahead and walk through these steps, and then I'll come back and walk through them together with you guys. All right. I don't know why that's not working. So I'll cut and paste this into the chat. And we'll take another 5 minutes to walk through that exercise. I'm sorry, we'll take 5 minutes to give you guys a chance to do this exercise, and then I'll walk through this with you. The first sets of exercises that we're going to be doing today are pretty straightforward and pretty easy. And when we get to some of the later exercises in terms of blue-green deployments, replication, and recovery, those get a little more complicated. So that's why it may feel like we're going a little bit fast right now. But trust me, we're not. We're doing pretty straightforward things so far. If you guys have any questions or need any help or want me to slow down, please let me know, either through the chat or by turning on your microphone and just shouting out to me. All right. So let's go ahead and spend the next 5 minutes or so walking through this or doing this exercise, and then I will walk everyone through it as well. All right. So has everybody had a chance to walk through this first bring your own container exercise? See here. In this exercise, what we're going to be doing is deploying this Postgres test container. So I create a demo dash and my student ID. In this case, the example in the animation here is terminal 49 for student 49. What I'm going to do is I'm going to create a demo dash 49. For myself, I'm creating a project called demo dash 20 because I am student number 20 here today. Demo dash 20, I'm going to call it demo dash 20, the display name. I like to add a display name because it makes it a little bit easier in some of the displays that we work through. I'm going to minimize the terminal for right now, and we'll restore that terminal later on if we need to, and that's down here at the bottom. So we can open up the terminal. So we get this nice window down here at the bottom, which allows us to work with that. Let's see. And the next thing I'm going to do is I am going to like add a container image to an existing image from the container registry. So I have an image that's already available to me in some type of container registry. And let's see here. In this case, interesting. Here we use the Sonatype Nexus OSS. On the command line, we used a different one. So I'm going to go ahead and use the one that's listed here. I'm going to search for Sonatype Nexus OSS. Notice that the OpenShift container platform comes with access to already available registries that are provided by Red Hat, as well as Red Hat vendors. And let's see here, image name from external registry, validated. So it went out and it was able to find this because the OpenShift container platform already has an index of container registries that are available from Red Hat as well as Red Hat vendors to be able to easily deploy on an OpenShift infrastructure. What else do we change? I forget here. We are going to, let's see, enter the values shown above. Application name is Nexus app. The name is Nexus. We're going to have a deployment config resource. We are going to create a route. Creating the route is what makes this available for us to be able to access from the web, from the internet. We are going to show advanced routing options because we're going to also have to specify a path. Do not forget to specify the path. If you don't forget to specify the path, in the next exercise, we're going to see that we're going to get an error. So make sure that we create the path when we deploy this image. See here, we have a deployment config. Going to create a route option to this. The name is Nexus. The application name is Nexus app. And advanced options, yeah. Oh, there is something that I left out, which was the path. I should have clicked on the show advanced routing option. So let me go back and correct that just now. See here, big maps, my project. Going to be Nexus route. Path. Route spec path. Listen how to add this right. Labels, location. I have to edit it in the YAML, and I forget exactly where to put it in the YAML right now. Back here. Port path. If I remember correctly. Here. Nexus. Go ahead and save and reload this. Now, if I go back to my details, yes, excellent. It should list my path here. All right. Now, I should be able to, let's see, click create. So if I go into the next lab exercise, and let's do this next lab exercise together, because this next lab exercise is simply reviewing the container details. So if we want to, through the command line interface, we can run the OC project demo 20, which changes our context from the terminal project that we were working in. I'm going to go ahead and see for the terminal in here, OC project. When I type in OC project, this is what's going to change my context in terms of where I'm working right now. If I run the OC status command, this will tell me which project I'm currently working inside of. In this case, I want to work inside of the demo 20 project. So I run the OC project demo 20 to get there. And what I'm going to do next is OC get all. This is going to show me all of the details available to me that OpenShift has about this particular project. What we'll see here is a lot of data that comes out. Let's see, I'm going to open this in a new tab so that I don't have to look at the bottom half of the screen. I can see the entire terminal, one screen here. All right. It'll take a second. There we go. OC status to make sure that I'm in the right place. OC get all. What we see here is that we have a pod, we have a service, we have a deployment, and a replica set. The pod has 2 of 2, and they're both running. We have 0 restarts, and it's 17 minutes old. The service has a workspace with a cluster IP configured for it, and port 4444 in order to be able to access that. And the deployment, we have one deployment, which is a configuration or a collection of services and pods as well as routes. And the replica set tells OpenShift how many of these pods we should be running behind our specific service. And we have one, and that's what we've got running right now. So we can get, let's see here. So now let's look at what our image stream. One of the things you'll note is that there are abbreviations for specific things. I could type in OC get space image stream, all one word together, and that'll give me the same output as OC get is. In this case, we want specifically OC get is/nexus to see the image stream that was used to build this particular /nexus, this particular application. Sure. Hold on a second here. Oh, describe. Right. Typing is a very OC nexus nexus not found. Why is that? Aru? Do this through the web interface. I believe I'm typing something in incorrectly here. Close this guy. Yeah. Let's see, where is my namespace? Where is my image stream? Project. Details. Builds technology. Big. Containers. It's registry. Here's my image stream. Why is it not showing it on the other? Huh. Minus variables. Yeah, so this is my image stream right here, image registry OpenShift. This is where my image was pulled from in order to build this particular application. I went through this yesterday. We see describe pods. Let's take a look at the pods that we've got here. Here we go. So we get a lot more detail if we take a look at the pod itself. So here we see that our pod, yeah, here we go. We've got our image ID and where the image was pulled from. Oh, no, that's this terminal. In the right project? Oh, I'm in the terminal project, that's why. Project Nexus. All right, so remember, OC status is a very important command. All right, now, oh, Nexus, it's MO20. Okay, so the OC project MO20, OC get IS, get image stream. This will show us our image stream, get image stream / Nexus. There we go. All right, so that will show us that. OC get pods will show us our pod information. OC describe pods will describe our pods for us. Successfully assigns demo 20 Nexus 1 deploy to these systems, adding an Ethernet address, created the container, started the deployments, and we've got our deployment up and running. So now, let's see, we can see those details in the web console too. Make sure we're developer. We need to change it to administrator, the context, in order to be able to see some of this stuff now. That's right. Couldn't quite see it there. So let me go ahead and change that context. So this is administrator of my specific context logged into the system as user 20. So demo 20. I'm not an administrator for the OpenShift platform itself. I'm an administrator for these projects that I've created. So this is a multi-tenant type experience that we're working through in this workshop today. And let me see here. We've got pods, deployment, stateful sets, replica sets, storage builds, get where the image stream is specifically under. Builds, that's right, it's under builds, then image streams. So if we go to our builds and image streams, we'll see that we have our Nexus image stream, and this shows us our image stream details for the demo 20, where this image repository came from, when it was created, and how many of those images we're pulling from this stream. All right. So the next thing we want to do is we want to test out the application to see if it's actually available to us. If you switch back to developer and then click on the arrow at the top right, that arrow is this little guy right here. So let's go back to our developer context inside of the OpenShift platform. And we'll see the nice graphic that shows this to us. This open URL shortcut link, which is the arrow pointing out, should open up the Nexus. If we don't get this, if we get a 404, that means we didn't set up our path correctly. Now, if you went through the web UI just like I did and forgot to add the path in the advanced routing options, you can add that path back in by going into the project and going into the route and adding the /nexus path in the .yaml. And that's a little more complicated than what we should have done in the lab exercise, but it's one way to get there. So we should see the Nexus repository manager available to us. So now we have our own Nexus Sonatype repository manager already deployed inside of our OpenShift infrastructure for our projects to be, for managing our projects. So we could use OpenShift to deploy our own registry. And Sonatype has some interesting features available to it, which is one of the reasons why we demonstrate this. some security scanning capabilities, and a bunch of other things available in the Sonatype Nexus repository. All right. Let's see here. Yeah, so troubleshooting. If you get the HTTP error 404 when trying to browse to that specific route, that's probably because we haven't set up the /nexus path for that. And we'd have to go back to the previous exercise in order to be able to correct that. Or you can drop me a note in the chat and I will help you fix that if you need some help with that. All right. So before we clean up, does anybody have any questions so far? So far, we've created 2 projects and we've deployed 2 applications. One's a terminal that's built into the OpenShift container platform. And we're using that terminal as our command line interface to be able to see our projects and manage our projects. And we've also deployed a demo project, which deployed the Nexus repository application. The last thing we're going to do before we move on is we're going to go ahead and clean all of this up. We're going to delete our project. So make sure that our context is in the demo 20 project. And then we're going to type in OC delete all selector app equals Nexus. And that'll delete all the things that we've just created from our OpenShift infrastructure. And the reason we're doing this is so that we have a nice clean slate to do the next exercise, in which we're going to do a source to image builds workflow, where we have a set of code that's available to us in a GitHub repository or a Git repo. It doesn't necessarily have to be GitHub. It can be GitLab or your own custom Git infrastructure, or what's the other one? Bitbucket from Atlassian, as well as a variety of other different Git platforms. As long as it's a Git repository, then it's pretty easy and straightforward. Pull in our code, have OpenShift build a container image around that, and then deploy that image as an application and container inside of the infrastructure. So let's go ahead and clean up our demo 20 project. We're going to do that by making sure we're in the right context. I'm going to go ahead and run the OC status command just to make sure. I can always run the OC project demo 20 command, which will tell us or change us into the right context. I like to run the OC status just to validate and verify. Then I'm going to run the OC delete all, and what is it? Dash or 2 dashes. Dash dash, yeah, app equals Nexus. Delete all dash dash selector app equals Nexus. And what this is going to do is the selector is looking for a specific set of objects that have the label app equals Nexus. When our application was created, let's see here, application. What we see is that we've got, where are the labels? Oh, I think the label's under administrator, if I remember correctly. We're going to talk more about labels when we get into one of the future exercises. See here. Details. I think it's in the details view. I don't have a label here. This is deleting all of the, all of the objects, not necessarily the project itself, right? So we didn't delete the project. What we deleted are the objects. In this case, here we go, app equals Nexus. All of the objects have the app equals Nexus label associated with them. The project itself doesn't have that label associated. That's why we're deleting it that way, is we want to make sure we delete all of the objects, but without deleting the project itself. So now, here we can see in the output that we're deleting the pod, the replication control, the service, the deployment config, the image stream, the route, etc. If I run the OC get all command after this completes, what we'll see is that we've deleted all the resources, all the object resources inside of the demo 20 project namespace. All right. Anybody have any questions on that? All right, so let's take a look at the next lab exercise. Deploying an app with S2I. Source to image is what S2I stands for. And what this really means is that we're going to take a set of source code available from some repository that developers have already posted, and I'm going to build a container image around that. And this is actually really easy to do with OpenShift. It's amazingly easy to do with OpenShift. We follow the command line steps to do that. We'll first open up our terminal, and then in our terminal, we'll make sure that we're in the right project context. We'll specify a new application. We'll give it a name. Then we'll give it the get URL for that project. We'll give it a specific context directory. This context directory is within this code repo here, and that's what that means. So we're going to essentially clone that repo, go into dc-metro-map in that code repo that we've just cloned, and then we're going to deploy this as a deployment configuration. So inside of this directory, in this code repository, there's a deployment config file that OpenShift will read and go ahead and deploy, build that application into an image, deploy it as a container with the pods, and a service will be exposed with this last command right here. So by default, the deployment config that's posted in this code repo doesn't have a service already exposed in it. So we have to run this last command in order to make it available on the web. Let's go ahead and take a couple of minutes and go through that and have everybody do that exercise. And on the next couple of pages, we'll see how we can manipulate this application with some fun variations and environment variables and such. Let's go ahead and take 5 minutes and walk through that right now, everybody. And I'll come back and walk through it with you guys together as soon as we get back. All right. So I'm going to go ahead and go through this exercise and do this with you guys. See here, I'm going to close up the page there. That one's all gone. And clear this screen here, OC status. Let me make sure I'm in the right context. OC project demo 20. Right project. All right, so what we're going to do here is we're going to create this new app. And this Git URL already exists. The developers have already posted code to it. There is a directory in that code repository called dc-metro-map. And we're going to deploy that using the deployment config that's in that directory right there. So I'm going to go ahead and copy and paste that and paste that in here. Ooh, why did that? Well, I did the right thing, but that was funny. Wraps the output like that. Huh. All right, so let's see. Let's do an OC get all to see everything that we've got configured here. And what we see here is that we have a service. One of the things, though, is that this service is not exposed to the internet right now. So this service is entirely internal to OpenShift at the moment, which means that other OpenShift applications might be able to gain access to it, but from external to OpenShift itself, there's no access to this application. So what we do is we run this OC expose service, and that's going to create a route, which is a network path from the internet to be able to get into the pod where this service is running. So the OC expose service DC Metro map is going to create a network path through the route, a network path through OpenShift, which is referred to as a route. Now this service is going to be exposed, and if I run the OC get all, it's going to show me that I have a route object also available, and it's going to show me the host and port. So it's got a application name inside of the project space .apps, which is a DNS subdomain created by OpenShift, and then the OpenShift instance name, which is the project or the workshop name that I created, along with the domain name available to us. And this is going to be running on port 8080. All right. In the next lab exercise, 3.1, we're going to take a look at the details for that. We're going to check out the build details. I already did a little bit of that with you just now. OC get builds. If we take a look at that, we'll see the build process that was used to create this particular application. So this was done from Git. This was a source build, and the name of this is dc-metro-map-1. -1 indicates that this is the first build. If I need to rebuild this, for whatever reason, I change the code and I execute a trigger that tells OpenShift to go ahead and rebuild that, and we're going to do an exercise like that a little bit later on. It's going to rename this particular build to -2, and subsequent additional builds that have different variations on what's already been built here will get a different suffix or a different numbering at the end of them. See here. We're also going to take a look at the logs for the builds. In this case, we're going to look at this specific build name. So OC logs build -dc-metro-map-1 will give me the logs for this particular build. So we got the image source signatures, writing the manifest, the image destination after we pulled in all of the source code itself, right? So we'll see here in the logs a bunch of warnings about things that have been deprecated, which happens all the time on the internet. We see here that we cloned, the first thing we did was we cloned that repository locally inside of OpenShift. We took a look at the last commits messages in that, and we make sure we made a log of that. Then we cached all those blobs, specifically in OpenShift in specific places. One of the things that's kind of neat about the way that OpenShift builds these images with the source to image functionality is that it does this inside of other containers. And as soon as these containers are finished doing their builds, the logs are maintained, but the containers themselves, and once the image has been created and uploaded to the internal registry, then those containers are deleted and destroyed because they're not necessary. As an OpenShift administrator, you'd be able to see all of this, but as an OpenShift user and developer for project administration, it generally isn't necessary for us to see how any of that stuff works because it works. As an administrator, we might have to log in to take a look at things if something's not working quite right. But this is pretty straightforward. And as we can see here, it worked very well. We didn't have to do anything. All right. And you've also got instructions for how to see that exact same information through the web console. If you're more comfortable with that, absolutely, by all means, go ahead. And this lab exercise will walk you through where to find that. So underneath the DC Metro Map builds as a developer, you need to have the context as a developer in order to see this. You can go into the builds, build details, and then there's a log tab, which will show you exactly the same thing that we just looked at on the command line. All right, so let's go ahead and take a look at the app in action. We can either do this from the command line by getting the routes and then copying the host ports into our favorite browser, or we can go through the web UI. I'm going to go through the web UI in this particular case. So I'm going to go in and let's see here in projects, demo 20. I'm going to go back to my project. Ooh, I'm an administrator right now. I want to go back to my developer context. And what I see here is that if I go back to my developer context, it's going to show me the topology, and I can either click on the details for the DC Metro map, or I can open the URL by using the right-hand arrow up here. This right-hand arrow should open up the DC Metro Map Demo 20 apps.ocp fiercesw.network. And this will show me all of the DC Metro buses as well as metro stations in the DC area. And I can't remember if these, yeah, these are being pulled real time from some API that's made available from the Washington Metro Area Transit Authority, if I remember correctly. So this is a real-time map of where the DC buses are. It's kind of neat. Unfortunately, we don't have a real-time map of where the DC Metro trains are, but much more useful to know where the buses are, I think, for a lot of folks. Ride the buses. All right. Gives us an example of what it looks like. You can click on the checkboxes to toggle on and off the individual metro stations or each colored line. Numbered icon indicates there's more than one metro station. So we deployed a sample application that was already built by a developer. We took their source code and had OpenShift all of the work to create an image and then deploy that image as a container. And then we exposed a route which made that service available to us on the internet. And we did that with essentially 2 commands. I don't know about you, but if you ask me, that's some pretty powerful stuff. Notice that there's also more information about creating new applications at this link here, which will take you to the OpenShift Container Platform application lifestyle documentation. All right. We're going to keep that application on our system because we're going to use that in some of these subsequent lab exercises. Not this one, but we're going to use it in another one. All right. Oh, no. You should have the DC Metro maps. Select the app and inspect some details. Oh, yeah. So I guess we do it in this one. All right. So what I'm going to do is I'm going to go ahead and give you guys, I think we're going to need maybe 10 minutes in this lab exercise because we're going to change some stuff. And we're going to modify this application by doing some interesting things through the OpenShift Container Platform. We're not going to modify any code yet. We're going to do that in some other lab exercises. Let's go ahead and take 10 minutes to do this lab 4. And I will be back with you guys in about 10 minutes. And you know, I wish I'd play some Jeopardy music for everybody because that would probably be a lot more enjoyable than just blank airtime. Fortunately, what we've got. But let's go ahead and take 10 minutes to walk through this lab exercise here. And again, if you guys want me to slow down, you want me to speed up, well, I don't think I can go any faster. If you want me to slow down or discuss any specific details about the OpenShift infrastructure or demonstrate anything, please let me know. All right. Let's go ahead and take the next 10 minutes to work on lab 4. And I pasted the link there into the chat. And I'll give you guys 10 minutes and then we'll go through it all together. All right, get back to it. Does anybody have any questions? All right, so in this instance, what we're doing is we have an application that either we have developed or our developers have put together for us. And we've got, let's see, we have our app already up and running on the system, deploying and managing an application in OpenShift. All right, so we should have the DC Metro maps running in OpenShift. And what we're going to do is we're going to modify it just a little bit. First, let's take a look at the app and some of the details about it. Let's see. Traceability for our running deployment, back to the container image and the registry that it came from. That's the image stream we were taking a look at earlier. And images built by OpenShift are traceable back to the exact branch and commit from the code. So let's go ahead and take a look at that. I'm going to go ahead and look through the command line interface. So I'm going to have the terminal open in another tab. Let's see here. I've got that open up over here. And I'm going to make sure that I'm in the right context. I'm going to run the OC status command. So I'm in the demo 20 project, and this is the DC-metromap-demo20. Excuse me, DC-metromap-demo20 URL. That's the exposed route to the service inside the DC Metromap application. So I'm going to run, let's see, the OC status command. We're going to describe the deployment config. And we're going to describe the deployment config by using the OC describe deployment config / DC Metromap. And that's going to show us a few things about this. It's going to show us which image was used to build this. Kind of interesting is that this image was built by us on the system. And yeah, we don't have that listed here in this output. Deployment is -1. That's our first deployment. Notice that deployments and builds all have version numbers associated with them in terms of suffixes. Every time we redeploy this, that is going to increment. It's going to increase. So this is for version 1. That's our message here. And it's been running for about 20 minutes now. This is generated by OpenShift new app. So the OpenShift new app operator is what created this. Right. See here, there are a few other ways we could get this information. Describe RC is the replication controller. IS is the image stream. -L indicates that we want long output, so we want verbose output. You can also take a look at the running pods. So OC describe pods is another way to take a look at some of the components that are part of this particular application. And when I do that, what I'll see here is that I've got one pod that's running. Probably pipe this through less. I think I did. Status succeeded. It gives us our IP addresses. These are all internal. Got the external services. The service is what's going to show me, and the route is what's going to show me the route is going to show me the DNS name. The service is going to show me the external IP address. All right, so this is my internal node. DC Metromap, my deployment. So we've got annotations. We've got information about how this container was constructed. Here's my container that's running inside of this particular pod. So lots of different ways to see the information. All right, so if I want to know more about the build configuration, I can, because we used S2I, the source to image build process, OC describe BC is going to show me the build configuration, and OC describe build is going to show me information about that first build. I'm going to go ahead and take a look at the build output here. I think that's a little bit more interesting. And that's going to show me that this was built, let's see, so builds demo 20 map completed successfully. So the build completed, oh, I'm sorry, we start from the top here. Yeah, no. Yeah, this is the build, yeah, from the top here. Successfully assigned demo builds. So first it creates a container called map-1-build. And it starts running this container on one of the internal nodes. Inside of that, we do a git clone. a container image, we start pulling the different parts and pieces. Most applications that are run as containers are usually built on top of some other base container that's already in existence. So for example, Red Hat has the UBI, the Universal Basic Image. And that Universal Basic Image is a very small, compact, with almost nothing installed on it, core from Red Hat. And there are UBI images for RHEL 8, RHEL 7, and RHEL 9 that you can use to build your application on top of. So the kubelet starts pulling in the base containers that are used underneath it, and then it begins building that particular application for you. So it then, let's see, created a container managed Docker file, container image, started container STI builds demo. Once it finishes the build controller then pushes that up into the registry. So let's take a look at build config here, and I can shorten this to BC. Sorry, with BC Metro Map, not without the instance -1. And so this will show me where that image then ends up getting registered inside of my OpenShift container platform and what it was built from, right? So this shows me all of the build configuration that was used to make that build. And it's an internal registry. Oh, it doesn't show it here. Did it show it in the previous output? Yeah, this is the internal registry location for this particular build right here. Notice that this is a Node.js application. So this Node.js, oh, and we did use the UBI 8 image. So we used a Node.js image that was built on top of a UBI image, UBI 8 image on our system. All right, so taking a look at the pod logs, let's go ahead through the web console to do that this time, just to change it up a little bit. So from the administrator view, so I'm going to change the context from developer to administrator. And then I'm going to go into my demo 20 project. And from here, I'm going to go and take a look at my pods. It looks like I've got 3 pods. I've got the builds, the deploy, and the actual application. Build and deploy pods, notice that these are completed. These are no longer running. 0 of 1, 0 of 1. They're completed. They're done. They essentially got shut down once they finished. What is running is my application, and it gets assigned a random arbitrary string to the end of that in order to differentiate it from any other pods that might be running underneath this in terms of replica sets and whatnot. Got, running, completed. Now let's look at the log for the pod running our application. So let's go ahead and click on the running pod. In here, let's take a look at the logs, which is right up here in this terminal. So here we can see that we are getting buses. So we're getting buses.json constantly in order to keep this application up and running. Let's see, environment, dev mode equals false, node environment equals production, debug port is 5858. So these are environment variables that are assigned. We'll see in a later lab how we can modify these environment variables to do some kind of interesting stuff with our application. And yeah, since we have our application open right now, the JavaScript on this application is constantly pulling that application to update it. And that's why we get those buses.json keeps getting updated right now. So that's this tab right here, hitting this application constantly, get new information about where the buses are. And right now our log is streaming. We can stop it if we don't want it to continuously update, or we can let it go ahead and stream so it shows us in real time what's happening within our application. The details of our pod as well as its configuration are available in the details tab. So if we go back to the details tab here, one of the things that's kind of interesting is we get details about memory usage, CPU usage for this particular application. We can also see the YAML that was used to configure this application. This YAML contains a lot of information about this application that's running in our system. And sometimes you might need to see this, but for right now, it's not terribly necessary. Notice that there is a sidebar which will describe the different components that are available in this output right here, and it'll give you links to where you can find information on what these mean, what they are, and where you can modify your application in order to change certain things. Notice that this is editable as well, so you can save and then reload. Really, you don't want to do that unless you're inside of the spec section of this. If you go into the status section, you can't change any of the statuses, but what we can change is anything that's underneath the spec part of this. So that specifies how this application runs. If you see over here, we're about 1/3 of the way down the page, and then the status is going to be down here towards the bottom third of the page. So the top part of this output up here is really going to be more metadata that OpenShift uses to build the container itself rather than anything inside of the container and how I want the container run. Spec section is what describes how you want the container run. So that's the stuff that you can edit. You don't want to edit any of the other stuff outside of that. All right, let's see, what else do we take a look at here? We take a look at the logs. Oh, some environment variables. So here's where we can modify some aspects of our application. So if it's database name and configuration variable, almost everything uses an environment variable of some sort or another. So I'm going to go ahead and use the command line interface to change an environment variable. What I'm going to do is I'm going to set the environment variable inside the deployment config, and I'm going to set the environment variable beer me equal to true. And what that's going to do is that this is something that's built into the application. The application is looking for the beer me environment variable already. And since that environment variable is not set, it's essentially ignoring it. I'm going to go ahead and set it, and I'm going to specifically set it to true on my application. And what that's going to do is if I take a look at my application, before I do that, the bus icons look like buses. When I set this environment variable, all of a sudden on the next refresh here, what I should see on the next refresh, due to the deployment strategy being set to rolling and config change trigger being set, OpenShift auto deployed a new pod as soon as I updated the environment variable. So it's a little bit more than the next refresh. I have to wait a second here. See, we should see a new deployment happening for this application here. So yes, so it terminated the current pod that we were running. So let's go back to our pods. And what we'll see is that it redeployed, and now it redeployed a version 2 of my application. So now I've got version 2 of the application running, and if I refresh this page here, I didn't need to refresh it, did it automatically. I see that my icons are no longer buses. My icons are now beer mugs, or I'm sorry, beer glasses. And they look like full beer glasses too, so jump on one of those and make sure that you're not the one driving. All right, due to the deployment config strategy, so we OC get pods with the -W. The -W is similar to the watch command if you're used to using Linux terminals or Unix terminals. If you type the watch command before another command, what it'll do is it'll keep repeating that command over and over. The default is, I believe, 2 seconds, although you can set the default to something closer to that. The -W here just repeats that screen. I believe it also does every 2 seconds. So we can set environment variables across all deployment configurations with DC-all instead of specifying a specific deployment configuration. What we did here. Notice that there are also instructions on how you can do that through the web console. And so, yeah, now we see beer glasses instead of buses for where each one of our buses are located inside of the DC Metro map. Well, so that's fantastic for environment variables, but passwords and private keys, we talk more about in the OpenShift security workshop. So if you guys are interested in how to specify passwords and private keys and how to secure those for your applications, go ahead and contact Olivia back at Fierce, and we can get the OpenShift security workshop set up for you guys. Now, one of the things that tends to happen is that I might need to get into a pod because something's not going right in the pod, and I need to see what's happening. Either I don't have enough logging properly set up, or the logging's not working, or the logging's not telling me what's actually wrong. There are a couple of ways that we can do that. Through the terminal, we can get the pod name, and then we can execute against that pod name with the OC exec -IT specifies that I want a terminal a pseudo terminal set up, a TTY, so that I can interact with it, and I want it to be an interactive session. And I specify the pod name. The dash dash indicates the command that I want to run inside of the terminal. In this case, I want to run the bin bash command, so I have a shell running inside of the terminal. Now, once I run that, now I'm inside of that application, that pod itself. So OC get pods, make sure that I'm in the right project. OC status, I'm in demo 20. OC get pods shows me the pods. OC exec minus IT, specify the pod name. In this case, that's this DC Metro Map -2 -R2 FTP. And then specify the command that I want to run inside of that with the dash dash prefix and then space the path to the full command. And that's going to put me inside of the pod. And now I can type in things like env and grep beer, grep for beer, and I'll see that the environment beer me equal is set equal to true inside of that pod. And then make sure that you type in exits. Otherwise, you're going to remain inside of the pod for any commands that you tried to run. The OC command will not work. Make sure you type in exit to get back out of that. All right. So next, we can clean all of this up by making sure that we're in the right project space. We can delete all of the objects inside of the app DC-metro-map, and we can also delete any secrets that were created. These secrets are webhook secrets. We'll talk a little bit more about webhooks in one of the subsequent lab exercises. So let's take a couple of minutes to finish that up and clean up our lab for today. And if anybody has any exercises or any questions on this exercise, please feel free to drop a chat or turn on your mic and shout out to me. I'm going to give you guys, let's see here, a little bit of time to go ahead and clean that up. Notice that there's also a poorly indicated link to the OpenShift documentation here, and this describes all the steps that we performed in this lab exercise. And this will take us to the container platform, the latest documentation for the container platform. And I believe we're using a pretty recent version of OpenShift for this workshop, 4.73 or I'd have to double check right now. All right, so let's go ahead and finish that up. We'll take a couple of minutes here, and then we'll move on to Lab 5, where we talk about webhooks and rollbacks. So I'll be back in about 5 minutes, folks. All right, let's take a look. All right, so let's make sure we're in the right place. Let's go ahead and clean up our last lab exercise, OC status, OC project, oops, project demo-20. That's where I want to be working in. Make sure that I'm there. OC status. Now OC delete all collector app pulls DC-metro-map. Delete all dash, oh, well, L label app equals DC metro map. This will do the same thing. All right, so now we've got everything deleted from there. If I run the OC get all command, it should show me that my pods are terminating. And in a few seconds, those will be gone as well. No resources found in demo base 20. Or in demo 20 namespace. All right, and let's see. Oh, we have to delete the secrets. That's right. I'm going to go ahead and paste that command because that's a lot of typing. And it wraps that in a weird way. All right, fantastic. Let's go ahead and move on to lab number 5. In lab number 5, we're going to talk about webhooks and rollbacks. So builds triggers. If code changes in the upstream repository that I'm using for my code, I can have my system, I can have OpenShift create a new build entirely on demand and redeploy that new build in my application. So we do need a little bit of configuration. So we're going to log into our GitHub account in order to do this, and we're going to fork the OpenShift workshop because we're then going to set up a build trigger and a code change webhook in that. So I'm going to go ahead into my GitHub account here, and I'm going to take a look at the Red Hat Gov OpenShift Workshops URL. They're both listed here in the project page, so go ahead and open that up. We're going to click on the fork button that's up in the top right-hand corner, right here. That's where we've got the fork button. And I'm going to go ahead and create a new fork. I don't have an existing fork of this project. I don't own this project, but because of the nature of GitHub and this being a public project, anyone is allowed to create their own copy of it. And that's what a fork is, a copy of that project that you can then manage on your own without being tied to the original one, but that has a reference so that you can go back to it if you want to. I'm going to create this under the Fierce software namespace that I've got access to. And this is the repo, is the source code for the DC Metro Map application. I'm going to create that with just the master branch because what we're doing is pretty straightforward and simple here. I'm going to go ahead and create this fork by following the instructions right there in the lab exercise, which is pretty straightforward. So now I've got my DC Metro Map, and we can see that we have a subdirectory here. The last commit was Mr. Andrew Jaycox's commit for the merge pull request back in 2020, it looks like. And this is the repo as a source code for this application. It only works with the OpenShift 101 workshop, which is what we're doing. All right. So what we're going to do next is, well, when we're using source to image, there are a few different things that we can use to rebuild the source code. Configuration changes, image changes, and a webhook. So we're going to use a webhook for this one. And what we're going to do is in our OpenShift web console, we're going to add the web app to our project, just like we did previously, but we're going to add in a webhook for this. We're going to specify a different Git URL than the one we used in the previous exercise. We're going to need to specify the Git URL for our account, for our fork of this particular project. And we're going to specify the type GitHub. So I'm going to add in a developer view under the demo 20, and then we're going to select the add functionality. So let me go back to the developer view. I'm going to go ahead and add. And what I'm going to add is from Git, import from Git. See here, select import from Git, and then I'm going to specify the URL that points to my fork software. So my Git repo is going to be this one right here. So let me see the code. Yeah, if I copy it here, this should give me the right thing. Let me see. Yeah, this should give me the right thing. So I can, in my GitHub URL, click on the green code button under my forked project. Make sure you're in the forked version of the project, not the Red Hat Gov one. Click on the green code button right here, and then copy and paste this HTTPS URL. And you can do that by clicking on the copy icon right here. So that'll copy that for me. And then I can import that into my OpenShift project. So I can paste it. So I've got https github.com, in this case, /fierce/software. Do not use Fierce Software for your copy of this. Use your own forked version of this. We want, let's see here. We're going to create the Git hook a little bit later. We do need to specify a context directory. So we do need to expand the advanced options here. Let me see here. The context directory is going to be /dc-metro-map. We're going to select Node.js because that's what this is built on top of. Node.js, there we go, already selected. We're going to use the 14-UBI, I believe we used the UBI 8 image last time. Does it tell us to use a specific one? No, it doesn't, but I'm going to go ahead and change that to the UBI 8. We're going to give it the application name DC Metro Map with the name DC Metro Map under the deployment config, and then we'll click on create down at the bottom. So let's see here, application name, DC Metro Map, and the name is DC Metro Map. I'm going to replace the application name and the name of this, and we're going to use a deployment config. Finds the template for a pod and manages deploying new images. All right, so we do want to create a route to the application, so it'll be exposed automatically. And I think that's it. When you are done, click at the bottom, click create. Yep. I'm going to go ahead and click on create down here at the bottom, create my application. Now I need to add in my webhook because I haven't done anything yet. So the Node.js builder template creates a number of resources, but what we care about right now is the build configuration because that's what contains the webhook. So to get the URL, we'll keep going through the web console. Let's see here. We're going to, in the administrator view, click on builds and build configuration. So let's go ahead and change our context to the administrator view. Then we're going to go into the builds configurations under the builds section, build configs. And we're going to go into the DC Metro map. And here we should get under basic details, build configs. Click the DC Metro map, see the summary of the builds. Scroll to the, oh, that's right, it's at the bottom of this window here. Bottom of the window, we get our generic webhook and our GitHub webhook, right? So we can copy the URL with secret, or we can just open up the secret this way. Let's see here. What we're going to do is we're going to copy URL with secret for the generic webhook. And then we're going to switch back over to GitHub. And then in GitHub, we're going to set up a webhook in GitHub, that URL. What that's going to do is that's going to tell GitHub that anytime we commit new code into GitHub, also do an HTTP request to this webhook, which is going to come back to our OpenShift container platform. And it's going to pull that URL from the OpenShift container platform, which is going to be an instruction to OpenShift to go ahead and download new code, build a new version of the application, so a subsequent version of the application, and then deploy that version of the application automatically. So let's copy this generic with secret right here. So I'm going to click on that link right there. And then I'm going to go back to GitHub. And in GitHub, I'm going to open up under my project in the settings tab. There's going to be a vertical list of settings. Once I open that up, and I'm going to go to webhooks. So I'm going to click on the settings link right here, which will then open up a navigation on the left-hand side for webhooks. Go ahead and open up the webhooks. Now I'm going to add a webhook. And I need to confirm my access here because I've got some security set up on my GitHub account. So let me do that. And let's see, pasting that in there. Payload URL is the one that we copied from the OpenShift container platform. That's this generic URL with secret that we copied. So I'm going to go ahead and paste that in right here, and that's going to pull in the API on the OpenShift container platform to update that. And the secret's already in the payload URL. So I shouldn't have to do anything else. Let's see. Change the content type to application JSON. Disable SSL verification for our workshop today. Normally, we want to leave SSL enabled types of situations, but because we're using self-signed certificates for our infrastructure, application JSON, you're going to disable this for our workshop today. Generally speaking, you want to heed those warnings and leave that enabled. And I think we're just pushing the event. Just push the event, and we're going to leave this as active. All right, so now any push to the forked repository will send a webhook that triggers OpenShift to rebuild the code and rebuild the application. And I'm going to go ahead and add that webhook. All right, so now we have a push webhook set up in our forked code of the software. Let's see. In fact, GitHub should have, yes, so if I'd have read that little blue message bar up at the top here, it would have pointed out to you that you have now sent a test trigger, which case what we'll see inside of our OpenShift container platform, if we go back to our project, demo 20 project, what we should see in the pods is that we have a build, a second build that's being executed right now. So we have our map2 build, which is running, and our map1 build should be shutting down here any minute. Oh, yeah, so once the build is done, the container is creating. Once the container is running, we terminate map1, and now we have our map2 build running. We didn't change anything, we just set up a new webhook. The webhook sends a test to validate that it can hit the API in the right place and gets a HTTP 200 response, which automatically triggers a new build because that's what we've configured our system to do. Now, let's test that, right? So in addition to setting up triggers for rebuilding code, we can set up all sorts of types of triggers to deploy pods. It can be due to configuration changes or due to an image change. An image change would be, for example, if I'm using a specific UBI image and all of a sudden there's SSL libraries that get updated. A Node.js update because there are bug fixes and security fixes that have been applied to that. So all of a sudden my images are getting updated inside of the registries. I can set up OpenShift to trigger a rebuild of that application so that I have the latest and greatest versions of those applications or code libraries built into my applications on demand. All right, so what if something isn't quite right? Let's say we need to do a rollback. See, this will not work in today's workshop as we've not made a second deployment yet. But let's see here. So, get pods, OpenShift has done a graceful removal of the old pod and created a new one. OC rollout undo. See if this actually works. This will not work in today's workshop. We've not made a second deployment, so this isn't going to work right now. So no problem, we can do that. But what you can see here is that the command to do that is actually pretty straightforward. OC rollout undo, which will undo the last deployment configuration. But because we've only have one deployment configuration, that's not really going to do anything in our infrastructure here. Let's see, let's take a quick look at our deployment configs. Yeah, we only have one deployment config. Yeah, and this hasn't changed, so there's nothing to undo. We have a replication controller that rolled out, but we don't have a deployment config that we've updated or changed. So that's not going to do much of anything for us at the moment. But this allows us to integrate CI/CD tools to do rollbacks with the REST API. So we can control pretty much every aspect of OpenShift through the REST API. We can tie that into all sorts of interesting tools. For example, the GitLab CI/CD or a Jenkins or any one of those other types of. So we saw how we can configure source code repository to trigger builds with webhooks. And let's see, I walked everybody through this, but in case you guys want to spend some time working on this on your own, go ahead and take the next 10 minutes, do that lab exercise on our own. And when we come back, we'll go ahead and move on to lab 6. That. Lab 5, webhooks and rollback. All right, so I'll be back in about 10 minutes and we'll move on to lab 6. If you guys have any questions, again, feel free to drop a note in the chats or turn on your microphone and give me a shout out. I'll be right here. All right. All right, welcome back. Anybody have any questions on these exercises so far? All right. Well, then let's go ahead and take a look at application replication, Lab 6. So one of the things that we might need is we might need to set up our applications so that they automatically recover, or so that they don't appear to go down to our end users. Because inevitably software is still, well, the best way to put it is that software is still buggy. So things are going to crash. If the hardware fails, for example, we might lose an entire set of pods, and that can happen pretty much anytime. However, the way to plan for such failures is through replication and recovery functionality. So we have the ability to set up multiple replicas of our application and our pods. All right, so before I get there, let's see, we do have a question here. Let's see, may have missed what to set to get the webhook to do the rebuild. Not getting a rebuild to occur even when I resend the test webhook. Okay, so let's go back through Lab 5 here real quick. So a builds trigger change code webhook. The way to do that is that, let's see here, we go back into, see, we've got DC Metro Map, scroll to the bottom, done. That's how we create it. Here we go. So the administrator, as the administrator, we go ahead and click on builds and the build configs. And what we need is we need to pull the generic URL, copy the URL with secret, the generic URL. If I go back into my MetroMap details, under the administrator context, and let me see here, my deployment configs, I'm sorry, not my deployment configs, project demo 20. Down here at the bottom, no, where was it? Build configs, that's it. So under the build configs, it's not under workloads, it is under builds. Yeah, under builds. We go into the build configs for our project. So again, we're under the administrator context. Make sure we're in our project 20. We go into the build configs for our DC Metro Map. Yeah, and in this case, we want to pull the generic one. For whatever reason, the GitHub one doesn't quite work correctly. So we want to copy the URL with secret, the generic URL with secret. And that's the one that we want to put into the webhook on our forked GitHub project, right? So we add the webhook and we put that secret in right there. I'm sorry, we put that URL in that contains the secret in it into the payload URL. Make sure to set the application, the content type to application JSON, disable SSL verification, and leave just push the event. You don't need to add the secret because it's already embedded in the URL. Then make sure that you update the webhook. And if I do this right now, what we'll see happen is that under my, is it going to show it under builds? Well, it'll show it under the project itself, but we should see a DC Metro Map 3 get executed here in just a second because the hook was successfully updated. And I don't remember if that sends another test if I update the hook. I think it does. No, it doesn't. Under recent deliveries, I think I can send a test from here. No, where do I send the test? Webhook. Webhook. Ah, fantastic. Okay, good to hear that. It worked. Excellent. All right. So, so some kind of neat and powerful stuff that we've got available to us here, right? So anytime we push new code, we can have that new code automatically deployed. So we have the beginnings of a CI/CD pipeline, right? A constant integration and constant delivery, or continuous delivery, I should say. Right. So all and we didn't really do anything. We've just added a webhook to our application in OpenShift. And as soon as developers push new code into the master branch, because that's the branch that we're using right now. Now, one of the ways to control that is to make sure that only the lead application developer is allowed to commit code into the master branch. Resend from the recent deliveries tab. That's right. Hold on. Redeliver. There it is. Yeah. Redeliver it. Payload will be delivered. Yes, deliver this payload. There we go. So we've got our next build triggered right there. So we've got our third deployment config triggered on the system right now. Yeah, so we've got, like I said, the beginnings of a CI/CD pipeline already. We've got our application already running. Our application is available to users on the internet right here. And as soon as we commit new code into our project, that code almost instantaneously, or within a few minutes, a minute or so, gets redeployed out into the public infrastructure gets redeployed into the production service, which is available here. So one of the ways to control that from a development standpoint and a production standpoint is to make sure that only the lead developer, or that only some type of an approval chain can merge code into the master branch that's being used by the OpenShift infrastructure to create those images. In that you might have forked branches for development and for testing, which are then other applications that aren't available to the production infrastructure, so that those can be tested. Once those are validated, gone through a series of tests and other configuration checks, etc., we commit to the master branch. We're sure that it's going to work, and then we can have OpenShift and our GitHub infrastructure automatically deploy that just by the nature of the commit itself. So some pretty powerful stuff, and really we haven't done a whole lot to configure that. We have essentially done these 5 or 6 steps that are listed here in this Lab 5 exercise. And we've got the beginnings of a DevOps type workflow available to us. Now, from a production standpoint, from an ops standpoint, application replication is important. In that if we have hardware failures or other software failures that might take our infrastructure down, we don't necessarily want that to impact the customer and the end user experience. So one of the ways that we can do that is by essentially creating more replicas of our application, which is going to spread it out over different workers, which are the different physical systems that are running the pod infrastructure for us, the container infrastructure for us. And we can do that by simply running the OC scale command and specifying the number of replicas that we want. We take a look at our application right now. Let me see here. We go back to our project and let's see here under not operators, workloads. We can see in our deployment config for the DC Metro map that we have one pod in our deployment config. In Lab 6, what we do is we can either go through the command line interface and specify scale replicas equal 4 for the deployment config, or we can do it through the web console, which is exactly where I was looking at right now. Specify workloads, deployment configs, and then what we get is the, excuse me, we get this graphic right here, which indicates that we have a specific number of pods. So right now, our default is 1 pod. If I increase this, that's going to scale it to 2 pods. I can increase it again to scale it to 3, and so on and so forth, and I can scale it to 4. And as it starts up each one of these pods is then available behind the service, because the service is going to essentially round robin, or depending upon how we've configured it, do a persistent connection. So for example, if I've got a customer that's coming in and I've sent them off to pod 1, if I've specified my service to do a persistent connection, it's always going to send that customer to pod 1. Customers that are connected to pod 4 always go to pod 4, or round robining, depending upon how my application is built. My application is a stateful application, and I'm using a database on the back end where each one of the pods has access to the database, and round robin is probably the most appropriate. If the session information is actually maintained inside of each one of the pods rather than an external database, then I probably want to do a persistent connection to each one of the pods. And that's all configurable in the service that's running in front of each one of these pods. That's part of the deployment configuration. And there's a lot more documentation and detail on the OpenShift documentation for how to do that kind of thing. All right, so we see what we have right now. We've got 4 pods running for our DC Metro Map application. Right, so we've got our deployments and builds. We've got 3 of those because we've done 3 deployments and builds. But in terms of the number of running pods, go ahead and resort this by running pods in the status. I've got 1, 2, 3, 4 running pods. Right, so each one of these running pods is running on a different physical worker node. Yes, in this particular case, we are using AWS for all the backend, so each one of these is running on a different virtual machine inside of AWS. And each one of those virtual machines should, in all good practice, be running on a different piece of hardware infrastructure inside of AWS, but we're all, but that's a little bit more difficult to control without going into AWS and reconfiguring a whole bunch. All right. So that's one of the ways that I can scale this. Now, we've told OpenShift that we'd like to maintain 4 running load balanced instances of our web app. In the next exercise, or the next portion of this lab exercise, what we're going to do is we're going to test that. So now that we have a more interesting replication state, we've got 4 pods running, we can test a service outage scenario. In this case, the replication control will ensure the other pods are created to replace those that become unhealthy. So we're going to forcibly inflict an issue and see how OpenShift responds. And we can do that through the web UI, or we can do that through the terminal. I'm going to go ahead and do that through the terminal. And what we're going to do is we're going to straight up delete a pod. That's it. We're just going to delete it. And we do that by first, we get the name of the pods from our system. And let's make sure that we're in the right place. It's always a good idea to run the OC status command. Validate that we're in the right place. We're in the demo-20 project, and we're looking at the DC Metro map. And let's see here. We've got a deployment configuration with a build configuration. We have deployment number 3 was deployed 5 minutes ago. That was the 3rd build. And we're going to go ahead and get the pod names. And we can specify, we can limit it to status equals running. And I forget exactly how to do that. Was it minus L status equals running? No. There is a way to specify this. I can't remember it off the top of my head right now. But recursive selector label. No. There's a way to filter this by status. Field selector. No, so first one, inverted type of fields to query. File name, customize, label columns. I don't remember what it is right now, but there is a way to limit that. In any event, go ahead and get our pod. So then I'm gonna delete a specific pod. Let's see, I'm going to delete, let's see this pod, for example. OC delete pod / pod name. And let's take a look at our system right here while we've got it up and running. So we've got these 3 up and running. And I'm going to go ahead and just simulate the failure of a piece of hardware. That piece of hardware went down. That pod's no longer available. Let's see what happens in our OpenShift. So we see that this pod is being terminated right now. And, well, look at that. It started up a new pod just a few seconds ago. So we already have the replication controller is going to do everything that it can, maintain the number of replicas that we've told it to maintain. We go back to our deployment configs, we can see that graphic, we can see that action in a little bit more of a graphic representation, right? So we've got 4 pods running here. I'm gonna go ahead and delete another pod because I'm a bit, I'm feeling a bit ornery today towards this particular application. Let's go ahead and delete that one. Whoops, I want this page here. So we saw 3 pods. Oh, it scaled back up to 4 pods, and it happened so fast that I didn't even really get a chance to show you guys. So what we see here is that OpenShift is pretty good, if you're fast enough, pretty good about maintaining the number of replicas that you have instructed it to maintain. So it got created and transitioned from pending to running pretty fast. And the service up in front of it made sure that everything kept running smoothly. And we can see more details about the deployment config with OC describe. Let's go ahead and run this OC describe command. Metro map. Yeah, deployment created, replication controller scaled from 1 to 2, 2 to 3, 3 to 4. Let's see here. This was created 32 minutes ago. And does it show me? Nope, this doesn't show me the pods. It shows me that we have 4 replicas, and our latest version of this deployment is version 3. Yeah, so we're good to go. And our replicas are 4 current and 4 desired. So our system is looking exactly like what we want it to look like. And notice you can do all of this through the web console as well. Through the web console, you can simply select one of the pods by going into the deployment configuration, clicking on the pods link up here. Back in the deployment configuration, or you can go to the workloads pods and select a specific pod, delete. Excuse me. And it'll do exactly the same thing. And then if you quickly switch back to the deployment configuration view, you'll see it scaling from 3 to 4 really quickly back up. It looks like at one point in time, there might actually be 5 pods running if you were to count each one of these segments, but really one of these pods is being deleted. It's going away. And this pod is being started up to replace it. What's happening? All right, so let's take a look at application health. And then I'll give you guys 10 minutes to go back through any of these steps and to review them yourself. All right, so OpenShift is going to watch all of the containers inside these pods. We're going to inflict some more pain on these pods again. In this case, what we're going to do is we're going to kill the application inside of the pod. Okay, so we're not going to delete the pod itself. We're going to execute bash inside the pod, and then we're going to run the kill9 command on the Node.js application that's running inside of that pod. So OC get pods, keep exec minus IT. I need to specify the pod keyword because the only thing I can exec anything in is inside a pod anyways. Exec bin bash. All right, so now I'm running inside of the pod itself. And I can run, for example, the ps-aef command to see what's running on the system. And I'm going to execute a kill-9. I know that the lab exercise technically has a pkill, which is a pattern kill. Looking for anything with the pattern in the process name that matches node. I can either do that, or I can kill the process ID 23 if I use the kill command. So this is going to kill that. And one of the things that is kind of interesting is that the bash shell exits almost immediately after that. What happened is that the OpenShift infrastructure noticed that something went wrong inside of that particular pod, killed it, and then it restarted a new one. It killed that particular pod, and then it restarted that pod. So it didn't start a new one, it restarted the same pod that it already had because something went wrong inside of that pod. Right, this is going to kick us out of the container with an error like error executing command in container, which is pretty much what happened here. Yeah, command terminated with exit code 137. And then we found ourselves back inside of our OpenShift terminal rather than inside of the pod that we were just looking at a second ago. Now, if I ran the watch command, I would see that container restart. If a container dies multiple times quickly, we get put into what's called a crash backoff state. And there are some parameters where you can ensure how often that happens, how many restarts, and that's more of an admin type function. So definitely look into the Red Hat OpenShift training course, the full training course for that. We don't cover that in these workshops. All right, so the last thing we want to do is we want to scale back down to 1 replica. because we don't need 4 replicas running on our infrastructure. We can either do that using the command line OC scale command, or we can go through the deployment config and scale it back down to 1 replica. And the reason we want to do that is the next lab exercise that we're going to do, we're going to talk about labels. Yeah, that lab exercise doesn't care how many replicas we have. It's, I believe it's lab 8 where we do care how many replicas we have. Well, let's go ahead and take 10 minutes to just review that lab exercise. I'm going to give you guys some time to do that on your own. And then we'll continue on with the next lab, lab 7. Again, if you guys have any questions, feel free to drop a note in the chat or to turn on your microphones and shout out at me. I'll be right here. And I will see you guys in 10 minutes. All right, welcome back. So what we've seen so far is that replicas and recovery from failures in the infrastructure by OpenShift are pretty solid and pretty easy to configure and set up. Another thing that's also pretty easy to set up are labels. And one of the reasons why we might want to use labels are for integrations with CI/CD software or other applications, right? So we can reference groups of pods, even treating pods with different containers as related entities, right? So if we want to group things inside of our project in a specific way, we can do that with labels. And that's what we're going to do in this next lab exercise. We're going to put labels on a pod, and we'll see in the next step, in the next exercise in this lab, how we can start using that. What we're going to do here is we're going to go into our running pod, and we're going to edit the labels for the running pod. And we're going to add in, let me see here, tested by my last name, or tested by equals my last name. And we're going to save that. And then we're going to manage the columns in order to see that in terms of the web output. And then we'll take a look at how to do that from the command line as well. The reason for doing something like this is, again, for integrating with a CI/CD process. We also might want to do that for oh yeah, we're going to do that for our blue-green deployments, which should be kind of interesting. That's the last exercise, the last lab that we do in this workshop is a blue-green deployment. So that's where labels are going to come in a little bit handier. Let's go ahead and run through this here real quick. And I'm going to do it through the web interface. I'm going to go in as the administrator. The administrator is responsible for the running application itself, whereas the developer is responsible for hooking up our OpenShift to build our images and make sure that our containers are running on images that we want with regards to the source code on the back end and things of that nature. All right, so let's go into our workloads and pods. That's administrator. We are the administrator. We're going to go into the workloads. We're going to go into the pods. Oh, I forgot to descale this from the replica state of 4. So I'm going to go ahead and bring this back down to 1 pod. Terminating all the others. And we're down to 1 pod, 1 running pod. All right, so I'm going to go into this 1 running pod. And under actions, I'm going to edit labels. And I'm going to add in tested by my last name. And it's a free-form box where I can create any label with any value that I want to in the box. And then I'm going to go ahead and save that. In order to validate or to ensure that that's been set up, consider filtering for status running. Yeah, we already did that. Labels, edit labels, save. So here, what we can do is we can manage the display, right? So if we go back to our list of pods, this display output right here, we can manage the columns that we're showing in this display output right here. What I'm going to do is I'm going to remove one of these. I can't remember exactly which one off the top of my head here. And scroll down to labels. Hold on, what do we remove? Restarts. All right, so we're going to move restarts in order to just compact this display a little bit so we can get it, the labels column instead of restarts column. And what we'll see here is that we have our labels column here at the end, tested by equals my last name. Again, the reason we did this is in the last lab exercise that we're going to run today, which is our blue-green deployment, we're going to use our labels in order to figure out where we are routing our traffic to in terms of a green and a blue deployment. And if you're not familiar with the concept of blue-green deployments, what that refers to is running a production application that customers are actually using, and then deploying an updated production application, and then being able to switch seamlessly from one to the other on our system. So while the green one is currently running, as I finish up all the work that I need to do for the new application, I deploy that as blue. And then instead of having to take down the green one, I leave them both running at the same time. And then I flip a switch in the service route to say, okay, instead of routing all the traffic to the green application, route the traffic to the blue application. And we're going to do that by using the labels, right? So part of our CI/CD process is what we're talking about. And that's the last lab that we're going to do today is our blue-green deployment, which is where we're going to do that. We can also be used for running apps on specific nodes. So I can make sure that these particular nodes only run applications with these specific labels on them, right? So East Coast, West Coast, things of that nature. Or, I've got a Kubernetes infrastructure that spans a couple of data centers. I might want to do that. All right, so let's take a couple of minutes and do that. Let's add in that label to our pod. And I'll be back in about 5 minutes for lab number 8, where we talk about our CI/CD pipeline, rounding that out a little bit more than what we've done so far. All right, welcome back. Anybody have any questions on what we've covered so far? All right, well then let's talk about the CI/CD pipeline and how we can take advantage of that in our OpenShift infrastructure. And what we're going to do is we're going to deploy a Jenkins application inside of a Jenkins server inside of our project. So CI/CD is continuous integration, continuous delivery. The idea here is that as we find bugs in our code, we fix those bugs, and instead of batching that fix of bugs into a specific release, simply fix the bugs, put them into our source code management system, and as soon as it's in our source code management system and passes a variety of tests for the specific bug, it gets updated into the production set of code so that we continuously deliver bug fixes into our production set of code, as opposed to doing it on a batch schedule, which leaves our code vulnerable to those specific bugs while it's out there in production. So continuously build, test, and stage the software releases so that we can reliably release on time and we can reliably address those bugs as they happen as quickly as possible. So what we're going to do here is we're going to create a new project called CI/CD dash, whatever your station name is, mine is 20. And then once we do that, we're going to instantiate a Jenkins server inside of our project. So I'm going to go ahead and do that through the web interface here. I'm going to go back as a developer, create a project. And I'm going to call it CI/CD 20. I'm going to give it the same display name just to make it a little bit easier. Yeah, so change to the developer. Yeah, select project, drop down, create project. We did that. CI/CD dash, whatever our project name is. Now we're going to instantiate our Jenkins server. I'm going to go ahead and do this through the web console as well. So we're going to click add, and from the developer catalog, we're going to select all services, and we're going to search for Jenkins, and then we're going to pick Jenkins ephemeral. Jenkins generally requires a handful of other resources behind it, so we're going to pick the ephemeral build, which is not something that you would typically do for a production infrastructure, but for a workshop environment, that's going to be just fine. Let's see here. Developer catalog, from the catalog. Notice that there have been some updates to the OpenShift infrastructure in terms of naming. So we're going to pull from the catalog is what we're going to do. And we're going to look for Jenkins here in our search. Jenkins. And we're going to select the Jenkins ephemeral. It's without persistent storage. So any data will be lost upon the restart of this particular Jenkins. Upon pod destruction, right? So all of the data, the stateful data is within the pod. So this template is only for testing. If I was going to do this in production, I'd want to pick one of the other ones instead of some type of persistent storage. So let's go ahead and instantiate this template. And let me see what parameters we need to specify for this. It's going to be in the CI/CD dash your station number or user number. We're going to call this Jenkins, and see here, we are going to enable OAuth in Jenkins, and I think that's it. Those should be the defaults. Jenkins is already the service name. It's already CI/CD 20. It's true. Yeah, and that's it. So let's go ahead and scroll down to the bottom and click on the create. So we're going to leave all the rest of these things. Allow the use of Jenkins, update center repository with invalid SSL certificates. Self-signed, false, check. Check is bypassed. Check, I think I need to set that one to false. True. It doesn't have that in the lab instructions, so let's go ahead and try that without it. All right, so now we've instantiated in our CI/CD 20 project a Jenkins application. All right, so let's go ahead and click on the Jenkins application and take a look at the details for it. we're going to create a small sample application configuration. We're going to use this Node.js sample pipeline.yaml. So let's go ahead and create that. Make sure that we're in the right project here. Now we're using the CI/CD 20 project. Perfect. We've got a Jenkins service and Jenkins application deployment configuration running on our system. Now we're going to go ahead and create our sample pipeline. Now what the OC create does is it's going to pull this YAML and it's going to use the YAML to create whatever objects are specified inside of the YAML. In this case, this YAML specifies a Node.js sample pipeline that OpenShift knows how to use and instantiate. So that has now been created. If I run the, I keep clicking over, I'm sorry. If I run the OC get all, let's see what was all created. So we created a service, Jenkins service, JNLP. We have our deployment configuration. We have a build config. And let's see here. That pipeline is, here it is. It's part of this build config, Node.js sample pipeline, Jenkins pipeline. From we can access Jenkins. We should be able to just click on the little right arrow in that developer topology view. So let's go back to our topology. Oops, we were already there. And let's go ahead and click on open that URL. We are going to get an SSL certificate warning error. Go ahead and click through those. And this should be using the authentication from OpenShift. So go ahead and click on the login with OpenShift, as Jenkins should be configured to use our OpenShift authentication. And I put that password at the very top of our chat. So if you scroll back up through the chat, you'll find the password is FI3RC3-0P3NSHIFT. So fierce-OpenShift. We're going to go ahead and allow the selected permissions, defaults there, and that'll log us into our Jenkins. All right. So now we can see that we can indeed access the Jenkins pipeline or the Jenkins dashboard. And log in with OpenShift, log in with your OpenShift username and password. Okay, so next thing we're going to do is we're going to start the pipeline. And we start the pipeline by changing into the administrator, choosing the builds and build configs, and then click on the Node.js sample pipeline. Builds, build configs, Node.js sample pipeline. Then, once here, we're going to choose from the actions menu, start the build. That's going to be over here on our right-hand side at the top of the page here, and we're going to go ahead and start the build here. Right, no stages have been started. If we go back to Jenkins, let me see here. In the build queue, we should see that all of a sudden we have a build pipeline in the build executor status. Yeah, we have a build pipeline, and that build queue is going to show us that build. I believe we're going to click on this, take a look at the details for this build. Run spent 36 milliseconds waiting in the queue. And monitor the pipeline's progress. Yeah, so when the pipeline starts, OpenShift uploads the pipeline to the Jenkins server for execution. Jenkins dashboard should indicate the following build is executing. And build details. We can see the build details in here as well. Yeah, so we can see the build details that we're reading back from Jenkins also in our OpenShift project builds page. And back in the OpenShift web console, watch the pipeline executes. In the developer view, select the topology, and under CI/CD 20, Confirm the application is available once it completes. So right now, we still haven't completed everything. We're still in the build stage. And let me see here, status, progress. There's a way to see this in real time in Jenkins, and I don't remember what it is. By getting the console output. Yeah, we can see it in real time here in Jenkins itself. All right, let me go back to my OpenShift dashboard here and watch this build. And once that's done, we should be able to go to the topology and open up the Node.js example link right now. We already know that Jenkins is running. Now we're waiting for the Node.js application that we executed the pipeline from Jenkins. And we should see the Node.js CRUD application. It demonstrates how a Node.js application implements a CRUD endpoint to manage fruits. And CRUD is a database acronym for which I can't remember all of the details. Create, replace, update, delete, I think is what that stands for. But it has to do with database operations. So this is going to edit that for us. So in this lab, we very quickly and easily constructed a basic pipeline, provided that somebody else had written the YAML. If we wanted to see what that YAML looked like, we could simply open up the URL that we used for the pipeline when we uploaded it into our application. We did that, let's see here, back up here towards the top. So let's take a quick look at that YAML. Here it is, the sample pipeline. So if I open up this URL, what we see here is a Jenkins pipeline strategy, path of the template to use, name of the template that will be created, pipeline directive, closure from the directive pipeline syntax, pipeline agent node. So this is all instructions to Jenkins, whereas this is the Jenkins file. Yeah, so the Jenkins file starts here, and this is the pipeline that Jenkins executes for us. And Jenkins is essentially a CI/CD application that helps us execute pipelines of different types of builds and stages and what happens for each one of those. Let's see here, the preamble OpenShift with cluster using project OpenShift project. Notice that this is a template, so a lot of these are going to be replaced as variables with different values. And creating a Jenkins pipeline is beyond the scope of what we're doing here today, other than simply executing it. So how to write all of this stuff and all of this stuff means is a little bit more complex than I have the time or ability to go into right now. But as you can see here, it's not terribly complicated other than the syntax being indented. This is a YAML file. It has to be very specific that way in terms of how it's formatted. Kind of interesting because we've embedded what looks like a JSON file inside of a YAML file. Jenkins files, if I remember correctly, are mostly JSON files. And JSON files don't care about syntax in terms of spacing and construct for the data. That's part of the file itself, whereas YAML cares very much about that. All right, let's see where our pipeline is right now. Deploy tag, woo! All right, so it looks like we're done. Let me go back to the developer topology. What I should get are two applications running inside of my project CI/CD 20. Let's go ahead and open up the URL for our Node.js. Oh, the application is not yet available. That's right, it was red. Crash loop back off. Oh, we have an error. View the logs. Finalization registry is not available. Uh-oh. Looks like I need to fix something. Finalization registry. What that is. Oh, it looks like I've got something to do here over the next 10 minutes. Hmm. All right, so I'm going to take a few minutes and see if I can look up what this is. Finalization registry is not defined because I don't recognize that particular error. All right, so I'll be back in about 5 minutes. You guys bear with me, and let me see what I can figure out. I'll be right back, everybody. Hey, everybody, sorry about that. Looks like Chrome crashed on me. I gotta get a couple things back up and running here. Give me 1 second, and we'll get back to our lab exercises. All right, sorry about that, everybody. Chrome crashed on me, so I had to restart everything and get back into it. All right, so let's see here. I created my sample application configuration, but that seems to have an error in it because it's not actually running my Node.js Postgres example. Go and take a look at the administrator. Deployment configurations. Row of 2 pods. Found. Controllers. Failed. I can understand. Oh, is the screen not sharing? Oh, my apologies. All right, that should be sharing now. Can you see the screen now? Excellent. Okay. All right. So I failed. Oh, let me go back to my terminal. Oh, it disappeared. Huh. That not entirely of spec, but unusual nonetheless. All right, let me see here. We created this sample pipeline. Back now. Okay, I just reshared it. Okay, good. Here. Replication controllers. This one isn't scaling to 2. A quick look at the YAML. Create timeout seconds, active deadline seconds. Oh, gone again. Oh dear. I'm wondering if I might need to reboot my workstation here. Can you guys see my video?
I can see it, Ivan.
Okay. But the screen share is not sharing.
Right now, I can see it up.
Oh,
Can confirm, I see it as well.
oh, okay. So, Mark, you might need to reload the browser page and log back in to the presentation. Not showing. Like I might have to delete this deployment config and redo it. Needs to come and go. The screen share. Never been able to see Ivan. Oh, interesting. Hmm. Postgres is running. Why isn't this guy running? Let's crash back off. I needed that log. Dang it, I need that log. I don't know why this is failing. Somebody must have updated this application recently or that YAML file. Crash loop. Oh, the deploy had an error too. Affected. Since what crashed. And it's been deleted. Fantastic. And unfortunately, I'm not a Node.js developer, so I don't know if I'm going to be able to resolve this right now. I'm not sure what this is complaining about. Const registry, new finalization registry clear. Finalization registry is not. There's something in this code that is not happy with whatever this Node.js version is. Hmm. Is running. That's going to fail. Yeah, this is something inside of the Node.js code that I don't understand. Node build is failing on CPU features build. Well, I don't know how to fix that either, Mark. Appreciate that you have a little bit more insight into that. Don't know what needs to be resolved for that. Oh, and the build. Okay, that's a good idea. I think the build pods are still here. Build logs. Oh, compatible, but package log JSON was generated. I'll try to do my best with it. CPU features. Android new features and file included from compatible function types. Three 36. One moderate security vulnerability. I mean, maybe. It's not easy to tell from that either. Package log. Sure. Yeah, this is a warning. Those usually don't crash the app. They could. FS events, unsupported platform FSS. OS Linux R664. What? Oh. Oh dear. Like this was built for iOS, Mac OS X. That again is a warning. No, I'm going to have to submit a bug to the authors of the repo here, Mr. Alex Jaycox, and see if figure out why this isn't working. That doesn't seem to match the runtime error. I'm not convinced that that build process error. I mean, it could be. Again, I don't quite know. These logs don't have anything longer. This guy with the crash loop back off. This log indicates that registry equals new finalization registry in the index.js. Finalization registry is not defined. That out. Registry. Launching the bot with Node.js and Next.js. Oh, I just like going to Reddit, but sometimes, oh no, it's Stack Overflow. Okay, good. It's a little better. It's a versioning issue. Huh. I wonder if this is also a versioning issue. Darn. Well, that is unfortunate. Jenkins had any information about the build. Well, I'm gonna have to spend some time figuring that out because I'm not sure why that's not working correctly. JS, start it up. Well, Mark, I don't know what to tell you. I don't know how to fix this at the moment. So I think I'll do my best to figure it out after we finish the workshop today. But I think at this point we're kind of stuck on that one. So what I'd like to do is move on to the next one. Build errors in the log windows about there. Yeah, those errors are warnings, really. But even then, I wouldn't know how to fix those either. I've never built a Node.js application outside of running this workshop and one other workshop. Debugged all sorts of other types of builds, but not Node.js. All right, so yeah, all right. Appreciate it. Thank you for bearing with me there. All right, well, in that case, let's move on to the last lab, the blue-green deployment. And let's see here. What we do is first we're going to delete all the Jenkins applications, and maybe I'll try redeploying that later on after we finish the workshop to figure out what's wrong. And if I can figure it out, I'll send out an email letting you know what the details were for that. But let's go ahead and do a blue-green deployment. And I think in this one, we're going to do something a little bit different. We're going to redeploy the DC Metro map. And this time we're going to use that forked OpenShift Workshop DC Metro map project that we use. So let's clean up a little bit here. Go ahead and see, I'm going to open up my terminal. Put this out into a new tab. Close that one. Yeah, all right. So as soon as that comes up, I'm going to go ahead and delete the, well, in the OCD, in the CI/CD 20 project, I'm going to go ahead and delete all the objects in there. Make sure I'm working in that project right now. OC status. Right. Go ahead and delete all of the Jenkins ephemeral work as well as the Node.js deployment. So, and then I'm going to delete the project itself. We're going to start a new project called blue-green-20. Or in this, in your case, I believe it's blue-green-1 or -2. I'm not sure. All right, so a new project, OC new project. We're going to call it blue-green. And we are going to deploy a new app, and we're going to deploy with, make sure that you replace your GitHub UID goes here instead of leaving it literally your GitHub UID. So I'm going to go ahead and specify this. And I'm going to get this URL here, workshops, and specify the context and as deployment config equals true. And note that the wraparound is just a little bit confusing, but it should do the right thing. That's just a weird artifact of this guy here. All right, so let's see, OC logs -f build config /green. So we can also watch the logs by taking a look at the output of when we create our applications. See right here, build schedule, use OC logs -f blue-green build. And that's what I'm doing, is I want to see the build output for this particular log. What I suspect is that a lot of these Node.js modules or NPM modules have been updated, and maybe some of these lab exercises weren't tested quite right. Now, I know that the DC Metro map application works. I didn't get a chance to test the that lab 8 application. All right, so if we go back to our topology here and we drop out of the CI/CD and we go to the blue-green project, in the topology, we should see the DC, the green application itself. And the green application, if I remember correctly, doesn't have an exposed service at this point. So I think that's the next thing we need to do is expose the service green. Let's go ahead and do that. Expose service green. And now in our topology map, we should see that we have a URL. So let's go ahead and click on that guy, and that should bring us to DC Metro map. Fantastic. All right. So what I've now got is I've got in my application using a route named green. Now I'm going to release a new version of the app and test it in the same environment. What we're going to do is we're going to go to GitHub and we're going to change this line down here from red line to silver line. This is in the dcmetro.jade file under dcmetromap/views project. So let me go to the DC Metro map. And we're going to go to Views. And we're going to look for the dcmetro.jade file. And then in here, one of the things that I can do is I can edit this file directly in this interface. And what we're going to do is we're going to be looking for this first form input that says red line right here. We're going to change this to silver line. So we're going to change this one word from red to silver in this file right here. I'm going to go ahead and edit this. This should open up a WYSIWYG editor for me, and I'm going to change this right here, silver. And I'm going to go down to the bottom here, and I'm going to commit the changes. And you can put in a message or an optional extended message, and that's changed red to silver. Is the new metro line that's going to be available for everybody soon to be able to ride out to the Dulles Airport. All right, now that I've got that done, the next thing I want to do is I want to deploy essentially the same thing, but in this case, instead of calling it green, I'm going to call it blue. So if I go back to my terminal, I hit the up arrow the right number of times, be able to get back to that same page. Woo! And here I should be able to type in blue and it should show up in the right place, but wow, that is just not working the way I want it to work. Something? Oh, it doesn't seem to be. That is convoluted. So I created a blue application of the same, I put it in the right place. I happen to get lucky. So now if I go into my topology, I should see that I have a DC equals a deployment config green and a deployment config blue. Only the green actually has a URL, has a route available to it, an external route. And that's what this lab exercise is walking us through. The next thing we're going to do here is that we've used the same code base. Because we didn't have a commit trigger set up, it didn't trigger a new build of the application because we didn't want a new build of the application to happen automatically in this particular case. So we don't have a Git hook trigger set up for this, a webhook trigger set up for this. In this case, what we're going to do is we're going to deploy it and then we're going to manually test it. We're going to manually switch it from green to blue. And the way that we can do that, we can either do that with the command line by editing the route green and then changing the name from green to blue, or we can go through the web console. We can do effectively the same thing by finding the blue-green application as the administrator, finding the route, then changing the route green, blue by going to the networking and routes and doing that. So I'm going to go ahead and do that through the web interface. Remember, change your context to administrator because now you're changing aspects of how that application is made available inside of OpenShift rather than managing the application itself from the developer's perspective. I'm going to be working in the blue-green application. I'm going to go into the networking and the routes. This is how this is made available externally to the rest of the world. And I'm going to change this. Let's see, I'm changing the service is what I'm changing here. And let me see, how do I do that? Edit, route. Right, so you go to networking, routes, click on the green route, then actions, edit the route, and that'll bring you pretty much to the same place as you would have found with the command line interface. And we're going to change the to route from green to blue. Edit route, go to the spec to section name green to blue. And this is in the spec right here. So I'm going to change this. Whoops. Blue. I'm going to go ahead and save that. And then I'm going to reload. And let me see here. My application has a red line in it. And if I reload this page, I see now that instead of red, it says silver. And I did that seamlessly. There was no interruption to the customers on that particular change and modification that I made there. And in terms of OpenShift, all it did was send the traffic that was going to the green service on the back end in the route, instead sending it to the blue service, which is the blue application on the back end. Now it's almost the identical code base, but I've made a change. Now, if I needed to roll that change back really quickly, all I have to do is come back in here and specify green, save this, and as soon as the customer then hits that page or reloads that page, what they'll see is that the silver is now red. So I can switch very quickly between different versions of my applications as long as they're running within the same project space, simply by changing the routes inside of the networking configuration for my project. Right, so this green route right here, all I did was change this green route by editing it to point to a different service on the back end. And if I'm curious as to the different services, what I'll see is that I have a blue service and a green service, right? These are the internal pods that are running inside of my system or inside of OpenShift right now for the blue-green project, right? So I have two running services right now. I've got the blue and the green services that are currently running. Those are the pods that are front-ended or back-ended on those services right now. See that by going over here into services. And if I click on one of these, what I'll see is that the pod that's running behind this service is the blue service. And the same thing for the green one. But all I did was change the routes on the front end, points to a different service. Now, this might be green as the routes, probably not what I want to call this particular route since I'm switching between the two of this. I probably want to call the route something like blue-green or call the routes Metro Map service. That way, when I do make the changes, it's not always the one or the other, right? And that, I think, brings us more or less to the end. Yeah. So if you want to read more about blue-green, there's a post right here with a longer description as to blue-green deployments. It's by Martin Fowler. He talks a little bit, or he talks quite extensively about how that works in production environments, and not specifically with OpenShift, but OpenShift is a fantastic way to do and manage that kind of a deployment. All right. Well, that's going to bring us to the end of our OpenShift 101 workshop. And now you got a pretty good primer on how to manage and deploy applications, both from existing Docker containers, from source code, how to manage webhooks and triggers, how to do continuous deployment, CI/CD, although I need to go back and fix and figure out what's wrong with that one lab exercise. And I'm pretty sure that that's a versioning issue with some of the modules that are in the Node.js application itself. And then we played a little bit with blue-green deployments and service routes modification and things of that nature, as well as replication and resiliency inside of the OpenShift architecture and OpenShift container platform for maintaining our applications performing the way that we want them to perform. And that's going to be it for today. Appreciate you coming, paying attention, listening, and asking good questions. I hope you've enjoyed the workshop today. And if you'd like to see other workshops or have any questions, feel free to email myself or get in touch with Olivia for setting up the next workshop. Olivia?
Yeah, thank you so much. I'm going to take over screen.
All right.
Just for a moment. Okay. Yeah, thank you again so much, Ivan, for taking the time today to take everyone through the workshop. Again, here is my information, Fierce's information, and then your Red Hat representative's information. But thank you so much again for attending, and you should see an email follow-up from me shortly just to get any other questions you have answered or set you guys up with whatever you need next. But that is all we have for you today, so thank you so much for attending.
Thanks, Olivia. And thanks, Mark. Until next time, I'll see you later.